Rogue black holes. Okay, so most black holes stay where they're supposed to. They sit at the center of galaxies, or they orbit near another star. They have a place. But some, and this is the part that I feel like nobody really talks about, some get kicked out. When a star explodes unevenly, the force of the blast isn't equal on all sides, and whatever black hole gets left behind gets launched, sideways, outward into open space, with no star, no orbit, no system, nothing anchoring it. It just drifts through the galaxy, in complete silence, giving off no light, making no sound, detectable by absolutely nothing, unless something perfectly lines up in your direct line of sight. And if one passed through our outer solar system, not through Earth, not even close to Earth, just the outer edges, its gravity quietly shifts everything. Planets nudge on their orbits, moons scatter, comets get flown inward, Earth drifts just slightly closer to the sun or slightly further away, and that's kind of a whole story right there. You'd never see it coming, and that's not trying to be dramatic about it. That is just the physics of something that produces no light whatsoever. Coronal mass ejections. The sun looks calm. From here, it just it sits there, warm, stable, predictable, and most of the time it genuinely is. But every so often, it just snaps. It fires a blob of superheated plasma into space at millions of miles per hour, carrying its own magnetic field. And when that field slams into Earth's fields, it drives massive electrical surges through everything conductive on the planet. 1859, one hit us. Telegraph offices caught fire. Operators were sending messages with their equipment fully unplugged because, and I know this sounds insane, the storm itself was powering the lines. People saw auroras in the Caribbean. The most advanced technology on Earth at the time was the telegraph. So the damage was, manageable, I guess. Now just take a second and think about what the most advanced technology on Earth is today. Everything runs on electricity. Every hospital, every water treatment plant, every power grid, every satellite. European of 1859 doesn't just knock out your phone. It destroys transformers that are custom built, that take months to manufacture, and that most countries just don't keep in stock. Grid goes down, hospitals stop, water stops, communication stops. Gamma ray bursts. When a massive star collapses or two neutron stars tear each other apart, the explosion releases more energy in a few seconds than our sun will produce across its entire 10 billion year life. All of that energy gets squeezed into two narrow beams and fired across the universe at the speed of light. Here is the part that actually matters, though. Because it moves at light speed, if one is pointed at Earth, it arrives the exact moment we see it. There is no gap, no warning window. You observe it and you are already in it. It's like, imagine someone shining the most powerful flashlight ever built directly at your eyes from across a room. By the time your brain registers the light, you're already blind. Except instead of light, it's a beam of radiation. And instead of blind, it's, everything on the surface is just gone. A burst within 6,500 light years tears the ozone layer apart in hours. After that, sunlight does the rest. Our own star, unfiltered, completely unblocked, just cooking everything on the surface. 445 million years ago, 85% of ocean life died at once, one of the largest mass extinctions in Earth's history. And surface creatures were hit exponentially harder than deep-water ones. That pattern, more death near the top, less in the deep, is exactly what a gamma ray beam from above would do. Some scientists think that extinction was a gamma ray burst. We'll probably never know for certain. Magnetars. Okay, so when a massive star dies, the core collapses. That's just normal. That just happens. Pretty regularly, actually. But in rare cases, the collapse doesn't just crush the star. It twists the magnetic field into something that I genuinely don't think our brains are built to process. It's called a magnetar. Its magnetic field is 1,000 trillion times stronger than Earth's. And I know, that number just kind of slides right off you. It did for me, too. So here's a simpler way to think about it. Earth's magnetic field is what makes a compass needle move. A Magnetars field from that same distance would rip the iron straight out of your blood, except you'd never get that close because it tears apart every atom in your body at 621 miles out. You don't burn, you don't explode, you dissolve before you even reach the surface. December 27th, 2004, a magnetar on the other side of the galaxy, 50,000 light-years away, released a burst. In under 1 second, it put out more energy than our sun will in 250,000 years. And we felt it. From 50,000 light-years away, it physically compressed Earth's upper atmosphere when it arrived. That was a distant one, behaving normally. About 30 have been found. Scientists think many more are hiding out there. And if one sat within 10 light-years of us, which in cosmic terms is genuinely not considered close, a single burst strips the ozone layer, and then our own sun becomes the weapon. Radiation pours through with nothing left to block it. We wouldn't even be mad at the magnetar. We'd be killed by our own sun.
Strange matter?
Okay, so everything is made of atoms. Atoms are made of quarks, specifically 2 types. Up quarks and down quarks. That's it. That's normal matter, everything you can see and touch and interact with. But there's a third kind, the strange quark. And some physicists believe that if all 3 combine in the right configuration, the result is more stable than anything else in the universe. More stable than iron. More stable than the atoms in your body. Think of normal matter like a house of cards. And strange matter, if this theory is right, is concrete. And when concrete touches a house of cards, the problem is what happens when it contacts normal matter. The atoms it touches rearrange into more strange matter. Those atoms do the same to their neighbors. It spreads continuously with no mechanism to stop it. A single grain landing on Earth eats through the entire planet, atom by atom, until nothing recognizable is left. Nobody has ever seen this happen, and before turning on major particle accelerators, scientists ran the numbers and concluded the risk was very low. Cosmic rays have been smashing particles together for billions of years without triggering it. The end of the universe. The universe is expanding. That's been known for a while. What became clear more recently, and this is the part that kind of changes everything, is that the expansion is accelerating. Galaxies moving apart faster and faster, pushed by something scientists call dark energy. It makes up roughly 68% of everything in the universe, and nobody knows what it actually is. We named it, which is genuinely different from understanding it. What it does next designs how everything ends. If dark energy stays constant, the universe slowly dies. The stars burn out, black holes evaporate over trillions of years. Everything just cools and dims and spreads apart until nothing's close enough to anything else for anything to happen. No light, no heat, no change, just cold, dark, infinite silence. Forever.